Sorry, I was trying to start with a moo and then my voice cracked. It was not cooperating. Good morning, everybody, or good afternoon, good evening, good night, etc., etc. Okay, so I will get into hellos in just a second. If Mitchell is, yeah, moo crack up. If Mitchell is in the chat, we have a slight problem with TTS, which is that it is up and running, but I can't authenticate. So the username and password that I used on the old installation does not seem to work on this one after it was moved. I think the issue is that Mitchell moved it to different infrastructure and the authentication stuff did not get carried over. So I might have to set up a new user or something. I don't know. But in any case, I can see it is running, but I can't log in. So, yeah. Okay. Before I get into everything else, I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. And so, therefore, we begin with... Oh, and also, before I start this, if you haven't already, thinking about your little nerd brag for today. Good morning to Stephen W., Crispy, and Stephen George, who says, happy birthday, everyone. Yeah, on the subject of cars. Ooh, nice. Mitchell has just... Oh, what is that? That is a different... Okay, I'm going to pause. Cars.app, because I just got a message from Mitchell with the authentication info, and I'm going to see if this gets me in. Okay, cast note, live stream assistant. Oh, this is awesome. So it looks like Mitchell's project. Sorry, I have to type a... I do not want to... I do not want to type that password. I'm going to open Discord and copy and paste it because it is a random character string. Looks like it is many characters long. So here we go. Here we go. Give me a second and we should have TTS up. And then we can get into it. So it's no longer saving. Yeah, looks like this is now a full-on thing for people running streams. It's doing something, I think. I clicked on the stream and everything got grayed out and nothing else has happened. Oh, it's loading. Yes, it is up and running. Now what we just need is a quick audio test. I'm sure it'll work. Okay, generating audio. Here it comes. Mitchell should say test, hopefully, in just a moment. It is sitting there spinning, saying generating audio. Okay, I will leave that to do its thing while I quit out of Discord again, and oh, 500 error. Okay, so there's something going on Mitchell's side. Okay, back to here. Good morning to, some call it fun, Tabraze. Oh, so Tabraze, I'd been having a nightmare getting secure boot working on my Linux machine. I think I've just bricked my NVIDIA GPU card because of it. No. Oh, I hope you haven't, Tabraze. I hope you can recover it. Gavin, good morning, Gavin, said, domain saved, thanks to your help. Assistance much appreciated. You are welcome. That was a... nobody else will have any idea what that's about. That was a back channel thing that Gavin and I were talking about during the week. Good morning to Simon and Sion. Unexpected Maker is here. Tech Nebulous. Mitchell is here, and Drew Jordan, and who else? Who else? Wagon Loads. Yeah, Wagon Loads. I think you did make it. Paul Schultz is here as well. Awesome. I just heard a lot of noise coming out of the other room. Oh no, it's just the dehumidifier, that's all. Okay, so hit me with some little nerd brags. Did I, hang on, do we have a problem? No. Did I show you any of the, I don't think I did. The reason I'm confused is I've shown other people and I posted in Discord about it. I don't think I showed you the Gridfinity stuff. So, let me... Jordan, got my yard mowed yesterday. Yes. Nice work, Jordan. That's a good nerd brag. I'm going to find... What am I going to find? Looking for a Dropbox so I can find some pictures. And then down to here.
Got my yard mowed today.
It worked. TTS worked. Okay. So, refresh, yes. Thanks, Mitchell. TTS is now working. This is something I've just been doing on, this is on the workbench for doing through-hole assembly after things come out of reflow. So when boards come out of reflow, they go into the yellow zone, which is reflowed, but they haven't yet had other parts put on. And this is the workbench in that particular part of the clean room. And yeah, so this is a little Gridfinity
Scott Miller
tool
said,
area.
Ack almost missed the stream.
But you made it. You made it, which is cool. Okay, so this is the Gridfinity base with little triangular supports, and it's just super glued on.
Fun said, hello all.
Hello, some call it fun. So yeah, Gridfinity base with some triangular supports underneath it to angle it forward a bit, and then some miscellaneous Gridfinity bins and things. It's working. And yeah, there's a little sharps disposal container and these things, which are solder spool holders. That's a 2x2 Gridfinity thing with a little slot for a solder braid to go in it. What else? Oh yeah, so there's that, and that is it after all the stuff is attached. Then I've also been doing it on my own bench, which is considerably messier, and it's a much bigger grid. So this is my main workbench where I'm sitting right now. Just to my right, this is what it looks like. So there's a bunch of Gridfinity bins, and some of it is just generic bins with stuff in it, and some of it is specific, like this one that I made that fits my cutters and scissors. And over here on the right you can see one which has got a pokey pointer, craft stick burnishing tool, a scalpel, a folding knife, spare blades. Got some Weha static, like ESD rated screwdrivers and things. Any other interesting things? No, not really, not on that. But the probably the cool thing, if I switch over to where am I going to go? Switch to this. That can be for later. This is we're just about to get into the Testomatic stuff. This is one of my little 3D printed solder spool holders. I just wanted a spool holder that would fit into. Why is that so zoomed in? Zoom out, out I say. There we go. So I just wanted a spool holder that would fit into a Gridfinity style thing, and it really irked me that it was not going to be an efficient use of the space. So I ended up pushing the spool to one side, which then opened up one side to put more stuff in, and I made a little slot that's just the right size to shove in some solder braid. So solder and solder braid goes into a 2U container, and that can just sit on the Gridfinity grid. And there you can see it. This is a static photo. This is not video, but that little spool holder that I was just holding, you can see it there. That is it. It just drops into the Gridfinity tray, and I can lift it out if I want to, or just pull the solder out from the front of it. Whatever is more convenient. Ooh, hang on. What was this? Sergio? What? What? Sergio just contributed $20. Wow. Says, I haven't had a chance to say thank you for saving my house from a blackout. Hope you remember and hope you can produce more Rack 32 boards. Saving your house from a blackout? I don't remember saving a house from a blackout. Oh, Grant is also here. Good morning, Grant. In Bendigo at B event. I'll need to watch later. Have fun at the B event, Grant. Who has anybody else? Oh, John says, help my son replace his wheel hub bearing. Cool. That's a nice nerd brag, John. Paul says, I learned about the obscure way that avocado trees flower. Okay. Sounds like there is an interesting backstory to that. And yeah. Okay, so Wagon Lies asked a question. Are you able to make chip-sized PCBs? Hang on, cough coming. Okay. Wagon Loads, was that a question for me specifically, or is it a question for the industry at large? Yeah, the smallest PCBs you can make. There is a lower limit to the size of PCBs you can make, or at least the size of PCBs that that can be made as standalone separate units without being separated out, and that is because of the way the PCBs are produced at the factory. And a lot of the time what we worry about with things like PCBs is what is the maximum size you can make, but in fact there is a minimum size that PCB fabs will support, and they will just not want to do it if it's too small. I don't know what it is, but it's, it's off top of my head, it's probably in the region of like 10 by 10 millimeters or something. You can possibly go smaller than that, but they just have problems with handling and all. So what I'm curious about is what your use case is here. And if you're making chip-sized PCBs, what would you put on those PCBs? I think the smallest PCBs I've made have been around the 10 by 14 millimeter size, give or take. Something like that. Okay, Wagon Loads asked, can you reproduce an HP 5082-7300 display? I don't know what that is. As in, okay, so let's see, HP, is that like a display? HP 5082, I am going to look this up, 5082-7300. What is that? Oh, okay, it's one of those. Okay. It is this sort of thing where you have little, yeah, it'd be quite cool to do something like this with like those little 1 millimeter RGB LEDs. So you can make an RGB version of this display. But I don't really know what the scale is. Oh, actually, you can get an idea of the scale from here. This is in a breadboard, which means each of these is 2.54 millimeters. So that's 5.08, that's 7.62. So that whole thing would be maybe 8 millimeters across, maybe 15, 16 millimeters high. Oh, Oh yeah, there's a view of it with a few of them. Scott says, I have a 7x9mm PCB in my hand. Didn't make it though. Ooh, that is a tiny, tiny PCB. Wagon Load says 0.6 inch wide. What? Okay. 0.6 times 25.4 to convert it to usable numbers. So, yeah, reproducing one of these with tiny RGB LEDs and making it addressable would be interesting. What is the geometry of these displays? Because they're showing different numbers, and you can, is it just a matrix? It looks like it may be, or are they different? Is that display different to that? No, surely not. How is it doing this? Well, this could be a... it looks like the LEDs are actually fixed in positions. Of course, numeric and hexadecimal indicators. Of course, we could go to the data sheet. But that seems like too much trouble right now. Oh, Sion said, under 15mm JLC charge double for V-score, etc. Yeah. Stephen George says, I have hit the minimum before. I'll see if I can find the comms about it. Yeah, the issue is not the... yeah, Sion's basically hit the nail on the head here. So the issue is not the resolution or the accuracy of the... Ooh. Gavin just sent me a message. Of the traces and things. Like you could design traces that fit within, you know, a few millimeters by a few millimeters if you just wanted to have a few tiny little things on it. Reproducing that is not the problem. The problem comes when it's time to separate the boards, because the boards are not made as individual pieces, they're made as part of a large panel, and then that panel needs to be split either by V-scoring, which is done with a CNC machine that cuts a little groove along the board and then it's separated, or by routing with like a CNC router that goes around the edges of all of the boards. And that means that the boards have to be held somehow, so you have a work holding problem, and the accuracy of the V-scoring is not as good as the accuracy of things like tracks and other features that you would put on the board, because the tracks and things are all done using optical alignment and optical exposure sort of methods, but cutting the V-scores is done by putting the whole sheet into a CNC machine and indexing it and then running the cutter along it. So if you're trying to cut, so the precision on things like the positions of all of the cuts is not as good, not even close to as good as the precision of the tracks, like track width and spacing, which can be tiny. So the problem is not making the tracks on a small PCB, the problem is cutting it up afterwards and handling it. That is where the annoyance comes in, and that's why they have the minimum size requirements. You can't say to them, make me a PCB that's 2mm by 3mm, because they just won't be able to handle it. That is the thing. Okay, so John says, we used to have a microwave oven that would knock out our Wi-Fi. I got rid of it quickly. Yep. Oh, Scott says, itty bitty buck regulator. Ah, I have one of those right here. In fact, this is a really interesting sort of thing. In fact, this justifies firing up the microscope. Let's see if I can get the microscope going to show you something that Lachlan dropped into me a couple of weeks ago now. And then what do I need? Oh, I need power on that. Do I have microscope power? I do. Okay. Let's see if we can get some focus on this, and then I'm going to switch over to a microscope view in just a second. And here we go. So this, just looking at the top of that, that looks like an inductor, doesn't it? You can't really tell anything else about it. But look at this. If I turn this over, whoop, you'll see that it's made on a tiny size PCB. And hang on, I've got to get it back. Where's the microscope? There it is. Look at this. So on the bottom, it looks like a QFN sort of style thing. This is a voltage regulator module. And you can see that it's made on a tiny little PCB. And all you can see on the top of it is what looks like an inductor. In fact, it probably is an inductor. And in fact, I have no idea how they've even made this thing. But this is like a 2 amp or something voltage regulator. It's a crazy, crazy thing. And you can see from my tweezers the scale of this. Now I'm going to introduce a ruler just so you can see something of what's going on. Okay, so this is a ruler that is, these increments are millimeters. That's 1, 2, 3 millimeters. That large thing there, that's 1 centimeter. So that's 5 millimeters. And I'm going to bring this back down here. So this whole module is basically it looks like a 3 millimeter square. And it's made on a thing that seems to be like PCB material. It's, I don't know how thick it is, hang on. Oh, I'm trying to pick it up kind of on its edge. You can see that it's a PCB, it's like a fiberglass sort of material. So it seems like a PCB that's maybe, I don't know, at a guess, 0.2 of a millimeter thick. I'm going to grab the old calipers. This is going to be hard to do under the microscope. You can see the scale of it just by looking at this is my calipers. It's like a prehistoric monster. Okay, I'm going to try to measure. I'm trying to get this thing onto its edge so that I can measure the thickness of the PCB. Here we go. So I got to zero this out. 0. And not there. Come on. I'm trying to do this from a distance so that it can be, so that my head is not in the way. Where are we? There, okay. Try to get it on there. 0.3, yeah, it's reading as, where is it? I've got to find the scale. It's reading as 0.29, so essentially 0.3 millimeter. It's a 0.29 millimeter thick PCB that is 3 millimeters by 3 millimeters. And it's got some parts underneath that inductor, I believe. It'd be interesting to pull this apart and see how it is done. I don't know how they fabricated it with all of the other stuff in there. I can't even see where it is. Somewhere below that inductor is whatever the actual regulator is that does all of this. So yeah, anyway, this tiny little thing, you drop it on a board, solder it on like a QFN, and you've got yourself a voltage regulator. Yeah, I think it's a fairly new one. This particular regulator is a new design. Hasn't been out that long. Very cool. Yeah. Tabray said the electronics must also be packed into the inductor package. You still need a FET and control circuitry. That's right. Yeah, you still need, yes. And you could see on the bottom of it, like if I switch back to here again, you can see on the bottom of it, it's got 8 pads plus the copper pad in the middle, and those must be passing through to the control system somehow. Gavin asked voltage range of little toy. I can't remember, and it would take me a while to look up the data sheet for it. Sion said they laser separate those. Yes, that makes sense. So, which is a much more specialized process, but once you get down to that scale, it's like when you, and this is why there are like thresholds for pricing of things. Things like via sizes. If you go with vias down to a certain size, they can be done with spinny metal drill presses. They've got these big CNC presses that drill all the holes in the boards for making vias. But then once your vias go down below a certain threshold, the spinny metal drills are no longer a reliable way to do it, and they have to switch to things like using lasers to cut the holes for the vias. And that's why there are price ranges. So if you order a PCB with vias down to a certain size, like typically 0.25 millimeter or somewhere in that sort of ballpark, it'll be done with spinny drills. And then once you go below that, they have to switch to a whole different process using lasers to drill the holes, and then the price jumps up. So yeah, this is another one of those examples of there are things that can be done, but by doing it, it may not be economical. Scott said, pair of pics in DM you can show as an example of tiny. Ooh, okay. Okay, I'm going to reopen Discord and see what Scott has sent me. What are the... Here we go. Pics from Tinker. Okay, this is... Hang on, I'm going to... Just to make sure I don't dox this. Where are we? Forward, open in browser. Here we go. Just so I don't dox Scott. Okay, so this is a picture that Scott just sent. There's one. Where's the other one? Oh, this is the other side of the same module. Open in browser. There. Look at that. Tiny little PCB. So there's an inductor and a capacitor on one side, and on the other side, it's got a couple more capacitors and the voltage regulator itself. Yeah, cool. So V1 ground V, so it's in ground out. Basically, this looks like a drop-in replacement for a, what is it, a TO92, not TO92, TO220 style voltage regulator, like a 7.4 series, and it would fit into the same size. What is it, 3R8, 6R8 inductor. Cool. Yeah, that's a little board, Scott. Okay. Sion says outside the box, the big ground pad that goes to a bigger and ground on our carrier PCB. Yes. Yes. And also, okay, so Crispian said, how does that dissipate enough heat to deal with 2 amps? And what Sion pointed out is that big pad in the middle is a thermal ground pad, and that will send excess heat down and dissipate it through the PCB. But there is also another factor in this, which is that the... Hang on, I've got a cough again. And the other factor is that the efficiency of... No, not efficiency. Well, okay, the secondary effect is the efficiency of switch mode voltage regulators has continued to improve in recent years. When I say efficiency, I mean you put a certain amount of energy in, you get a certain amount of energy out, and the difference is dissipated as heat. And they are heading very close to 100% efficiency. Now, so if you put in 10 watts, you get like 9.8 watts out of it, but at a different voltage. And the reason they are becoming more efficient and the gap between the energy in and the energy out is getting smaller and smaller is that the forward voltage drop on the MOSFETs that is used in the switching technology is getting smaller and smaller because the I don't know, the chemistry, the physics of it, the geometry of the MOSFETs just continues to get better, with the result being that they are, and also they tend to run at much higher frequencies now. So as you get into higher frequencies, what happens is the inductor gets smaller and the time and the transistor can be very saturated. So it'll be either fully on or fully off. And it is in the transition that you get the heat, you get the energy, like the heat dissipation. So if you run a high speed, oh yeah, Stephen George says gallium nitride, GaN, yeah. So the new MOSFET chemistries and physical structures allow them to very efficiently change between fully off and fully on and do that transition incredibly quickly, which means that they are not in that intermediate period where they are partially conducting, and partially conducting is death for MOSFETs. That's where the energy has to be dissipated. So yeah, it's a side effect of the improving underlying material science that goes into making the MOSFETs that are then used to make the voltage regulators, which is all very, very cool things. Okay. Tabray said, have you seen the PCBs with components embedded inside it? I don't think I've ever seen one for real, like in my hands. I've done a few times, I've done boards where there are cutouts in the boards and parts protrude through, like for clearance of large capacitors and odd things like that. But I think what you're talking about is where you have a PCB and there are parts physically inside, like between the layers of the PCB. I have not seen that. Yeah. Stephen W. says, need a link to the datasheet for that tiny switching regulator. Yes. I would really have to look up. It would take me a while to find it. That little regulator has been sitting just in front of me on my bench, sitting on top of my computer for a couple of months now. And when Lachlan came in and said, hey, check this out, and showed it to me, and he did send me the data sheet at the time, but it was a couple of months ago, and finding it, yeah, you'd be spending the rest of the, you'd probably be spending the rest of the stream watching me try to find a data sheet. Tabray says it's probably running at a high frequency to bring the inductor size down and a synchronous design. Yep. Exactly. Gavin asked, any suggestions for an isolated 12 to 24 volt DC into 3 volt DC out regulator looking to run a multimeter without batteries internally, net output to be decoupled from the power source supply? That is a good question for everybody in the chat. I don't know the answer to that one. For the decoupling is the issue there. I'm just going to bring this up here, because one thing that is kind of annoying is later if people are trying to watch these streams and they're not, they don't have access to the chat necessarily. Sometimes you do, sometimes you don't. So, Tabray says, I put some part numbers above for similar parts. Ooh, where? Tabray's. Tabray's. I'm looking for your comments. Oh, here we go. FS, this might be it. Let's look that one up. And in a second, I want to get onto the Testomatic because it is sitting there on the bench beside me ready to do fun things with. I've made some good progress with it. Yeah, this is not exactly the same, but it's similar. So this one is 5 volt 3 amp. Look how small these things are. It is crazy that you can have a, yeah, look at this. So it'll do up to 16 volts in, 3 amps, 5.5 volts max out. So input of 8 to 16 volts. And let's check the dimensions on it. Now this one is not cheap, but that is a crazy size. So where's the footprint? Oh, look at the footprint on this thing. This is like a footprint from hell. Yeah, look at the weird pad shape on it. Where are we? So we've got I squared C data, so pull up to a bus voltage, blah, blah, blah. Okay, so it's even got an I squared C data interface on it so you can talk to it. I don't know why, but it's a, it's a voltage regulator with I squared C. Presumably you can do things like set current limits or read current maybe, I don't know. Read temperature, check error states. It'll probably say elsewhere in the data sheet. In fact, I'm sure it will. Now, where is the footprint? What did I see there? Oh yeah, it's just an example circuit. Got some traces for, thermals. Thermal image. It's kind of cool. Here we go. Dimensions, 3.3 by 3.3 millimeters. Yeah. Tiny itty bitty little things. Very cool though. It is so cool to be able to drop a 3.3 by 3.3 millimeter module onto a board, and you got yourself a 3 amp rated, so continuous 3 amp. That's not like peak. It'll continuously run at 3 amp, presumably if you give it enough thermal coupling, etc., so you can get the excess heat out of it. But still, yeah, there are some amazing little voltage regulator modules around these days. Technology is cool. Yeah. Oh, TPS82. Let's check this one out. This looks, in fact, this could be it. This could be the one that I was just showing you. DigiKey. It doesn't look exactly the same, but it's pretty close. So what's this one? 17 volts in, 3 volts, 3 to 17 volts in, output 0.9 to 6 volts and 2 amps. Oh, that's a max. It's an 8 LDFN exposed pad, and it is 3 by 2.8 by 1.5 millimeters. Yeah, well, if it's not this one, it's very, very similar to this one. It's the one that I was just showing you right there. That one there is almost the same as this. So what's the price on here? Like, if we get up into the 100 quantities, we're talking about $5 something each, which is not super cheap, but it's not crazy either. Not for a little thing like this. So if you've got a space, oh yeah, and there are some other, there's another one there. If you've got a serious space constraint, you want to put a little voltage regulator in your project, and you don't mind spending $5+ on the voltage regulator, yeah, these things are amazingly cool options. Really nice. Okay. Tech Nebula suggested THM 10 series is isolated. If it is too small, there are a few more available. THM 10, let's see what this comes up with. And range of temp, DC, DC. Okay, so this is, okay, medical 10 watt DC, DC converters, DIP 24, 2-to-1 input voltage range, reinforced isolation. Yeah, so looking for medical voltage regulators is probably a really good place to start, because medical equipment typically needs full isolation, because it's often used in situations where it gets directly connected to a person, and you don't want to be zapping the person that you're connected to. So yeah, medical power supplies are a good place to check. So yeah, Tech Nebulous, thanks for that suggestion. That's an interesting one. Scott says, getting to the point it's not worth designing in your own regulation. Well, yeah, it's basically there already. I mean, I never actually design my own regulator. I just use like an off-the-shelf regulator and with the supporting parts like inductor and things. Yeah. Debray says, I had to repair a PoE door control unit that used that module, and it had so much space around it, I'm certain the designer used it because he or she was bored and wanted a new toy to check out. Yeah. Probably. PoE. If you're talking about the other module, typically with PoE you need to support 48 volts nominal, in fact more than that, like 56 volts, if you want to support proper commercial PoE, but it could be lower. Wagonlight says, can that medical power regulator be used to power an opto-isolated ADC? Well, I'm sure it could. It supplies 10 watts. Like if we look at, I'm just going to pick one. Okay, so 3.3 volts. Input is 4.5 to 9 volts DC. Output is 3.3 volts DC. So let's just look at this one and see what its specs are. 8.3 watts. So output current 2.5 amps. Output adjustment, output voltage. Yeah, this would run. I'm just going to be flippant and say it'd run 1,000 opto-isolators. Not necessarily 1,000 when you work out the actual numbers, because that would only be 2.5 milliamps per opto. But do you get my point? Yes. Oh, Tabray says it was a secondary regulator, often isolated PoE. Yeah, okay, that makes sense. So you bring in the 48 volts nominal of PoE and then drop it to like 8 volts or 7 volts, something like that, to give yourself headroom to then feed it into a secondary regulator, which would give you the 5 or 3.3 or whatever it is that you want coming out of it. Yeah. Okay. Now, where are we up to? 10:44. I've been chasing squirrels for for a while. Yeah, so what are we doing? What are we doing? All right, I want to, first, I will show you what I did yesterday. And I think we may be up to, this may end up being a red letter day for Testomatic, which would be really cool, a big milestone. Now, switch to no, not that one, this one, overhead camera. Put the calipers back in their special little slot in the Gridfinity. And, okay, what we have here is Testomatic V2, which you've seen before. And what I did yesterday, I'm going to unplug this for now. Oh, yes, also, you can see that there is now the Ethernet port in the back. So these are the pass-through Ethernet connectors, panel mount pass-through, same as Stephen bought. He ordered some exactly the same as mine, independently at the same time. Neither of us knew about the other until after we'd ordered. So you can see that it's now got an Ethernet connector on the back of the Testomatic, which is passing through to the Raspberry Pi. So now we've got convenient cabled Ethernet onto the back of it. And at the moment, this is all on Wi-Fi. So right now, this unit is powered up. It's connected to Wi-Fi. It's on my lab network. But if you wanted to, you could now power it off there. And I could even throw a PoE shield on that, and then the whole thing could be power over Ethernet. But we need But I'm not going to do that because we need power coming in anyway for supplying to the device under test. I don't want to, I mean, there might be a use case for PoEing the whole test chassis, but I'm not, that doesn't matter to me, so I'm just going to leave it like this. Okay, so the other thing I did yesterday was this. So this is a new test module that I just assembled. It's got the test pin carrier board in here with all the pogo pins in it, so I can prick my fingers, stabbing myself on those pogo pins. It's got the EEPROM on the front so that we can put an ID or something, even store test information on the test module, so that when we plug this in to the chassis, it can identify what module is loaded, so it knows what board it needs to test. It's got the power LEDs there, it's got breakouts along here for all of the signals, but because I've gone through a few generations now, a few iterations rather, of this design, the plastic outlines do not match the PCB anymore. So the PCB template that I've created for making these test pins has changed a little bit since I did the original fusion design for all of the laser cut plastics, and the signal breakouts are now wider than they used to be, which means the slot that is cut into this doesn't actually expose. You can see on the left side here, it comes to here, and the actual pins come all the way out to near the edge somewhere. So I need to adjust the fusion design for the laser cut part of this. I also need to change some of these holes because these originally were for M2 bolts and now I'm using M3, and I've switched to 20mm spacers in here, which gives more room for add-ons under the test pin carrier, which I'll show you in just a second. And that ties into the updated chassis, so that gap here, the thickness of a module, so if we're looking side on, the module comes into the chassis and it plugs in. This thickness is greater than it was before, which allows us to have deeper test modules if necessary. So, coming back to here, this is a test module for a client board. In fact, this is for a water cannon motor controller board. Oh, I just stabbed myself. There is now blood on a pogo pin. I'm going to show this because my client is okay with showing these things on stream. So this is the control board out of a water cannon. These are half H bridges, so it's got 2 pairs of half H bridges, and then it's got a couple of other H bridges for other things. And I need to be able to test this. I need to be able to load firmware on it and test it. And you can see it's got all these test points across the bottom. So these are exposed areas where the pogo pins can make contact. It's also got this big connector on it, which is a real pain because it makes it mechanically hard to fit it into the test chassis. And that is why the chassis has this weird cutout at the front here. That is to clear the body of this connector. And even the PCB has a big slot in it so that there is clearance all the way down. Even though I probably, in retrospect, could have done it without that slot in the PCB, because the module, when it's fully depressed, it's kind of borderline, but the bottom of this connector is right at the point of where the PCB is. I just wanted to make sure that there was definitely no obstruction there, so that it wasn't sitting on the connector and being held up off the pogo pins. And putting that slot in the PCB ensured that. Now, oh yeah, and you can see there are some little support intrusions here. So in the corners, the back corners, because this is actually made up of 2 laser cut layers. The bottom layer has these little semicircle things coming into it, and semicircles along towards the front as well. One there, so that when the board goes in, it'll go into the slot. You can push it down, and it sits on the pogo pins, but it's being held at a certain distance by those little mounting points there, 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 and there. So we can put it in and push it down onto the pogo pins. Right now there is no mechanism to apply pressure. There is no pressure plate and clamp mechanism that should be going down onto this. So I'm just going to push it on. But the idea is that in future, you will put this in, pull a lever, the pressure plate will come down and it will clamp the device under test in place on the module like that. And if I can get it sideways, you'll see that the connector is actually going partway through the plastic that is holding it all together because of that cutout. Now, this is an interesting one to test, as in this board is an interesting one to test because it has a couple of interesting features that will that'll force me to figure out how to do certain things in Testomatic, which will then make it more flexible. One is I want to be able to flash firmware onto this from the tester. Now that's a very basic function. We should do that for basically everything. Any board with a microcontroller on it, it should be flashable through the test chassis. So that's like apart from just supplying power, that is like that is table stakes. It's just one of the most basic things. And in this case, once it has been flashed, I also want to communicate with this board, with the device under test, using CAN bus, because this is a CAN-controlled motor controller, and I want to be able to send commands to it and have it behave in a certain way, and I want to be able to read CAN data from it because it reports its status over CAN many times a second. So we need to be able to power it up, flash it with firmware, and then communicate with it over CAN bus. So that means that the tester needs to talk CAN bus. Also, when it is driving its outputs, like its motor controls, I want to be able to do things like send a message on CAN bus saying, move the water cannon to the left. And to do that, it's going to need to take its X-axis motor control and drive that H-bridge. And I want to be able to measure that and load it. So, I'm going to show you the bottom of the test module now because there is magic under here. Big reveal. Okay, so on the bottom of the test module, we have two other modules. This module here is a CAN bus module, and it's got SPI on this end. You can see that there is an 8-way connector there. It's got SPI and power and stuff going to the module, and there's an onboard CAN controller. It's a, what is it, a 2550 or something CAN controller. Oh, Mitchell has just sent me a message saying refresh TTS. Okay, we can't be without TTS because I'm away from the computer just talking to everybody. Refresh. And not paying attention to chat. Oh, I've got to sign in again. And here we go, current stream. And I'll turn the volume up a bit as well. Ooh. Okay, there have been a few things that have happened. Let's see. Okay. Pete celebrates 29 months of membership. Things I learned. Chlorine and cheap memory sticks are a bad idea. All right, what happens? There it is. Cool. So that is working now. Thanks, Mitchell, and thanks, Pete. Where is the chat? I actually can't even see it right now. Where is it? It's somewhere.
Mitchell said testes.
Don't you say that, Mitchell. Okay, there's the chat. Okay. I has made all the fixies, all the thingies should be workies now. Awesome. So now we have memberships and all that stuff. Refresh it. Refresh it. Okay. We need it. Yes. Here it goes. Is it going to say it? Refresh it. Okay, I will refresh it again. I will refresh it again. Cashews? Did someone say cashews? Pete, thanks for the membership. That is awesome. Was that 29 months? I just saw 29 months as a silver supporter. Okay.
Mitchell R said, testes.
Yes. Okay. Like hard refresh, says Mitchell. I did like a shift refresh. I'm going to try it again. All right, shift refresh. And let's see what happens. So for, I'm going to bring this up actually. It's not going to reveal anything super secret. This is the updated interface. And so it's showing, oh, cable tie. Hello, cable tie. Yeah. So, system mode, dark. Here we go. This is better. Okay, now this looks more familiar. Nice. It should ask you to re-log in. Oh, it didn't. Yeah. All tokens are reloaded. Okay. Yeah, I just did a shift refresh and it didn't ask me to log in that time. All right. So, back to... yeah, Sion says module on a module on a module, module inception, yes. And Stephen says chunky boy resistors underneath. Yes, I will show you that. John Whip said, so you worked out your new testing program language and the protocol for test specification? I kind of have. I will see if I get to that. The very short answer is PyUnit. Yeah. All good. Okay, so back to here. Okay, so CAN bus module, which means that the Raspberry Pi will be able to speak CAN bus to the device under test through one of these test pins, where somewhere on here there is CAN high and CAN low. So that module does that thing. It's got the CAN controller and a fully isolated CAN transceiver. So the fully isolated transceiver protects the test chassis from the device under test if bad things happen. And the thing is, the whole point of testing something is that it may fail. For all we know, for example, there could be a solder bridge on the device under test that dead shorts V in to one of the CAN lines. So you might have a situation where you plug a device into test onto your tester and it injects 24 volts onto a CAN line. You know, some really bad thing like that. So yeah, this CAN module is designed to be fully isolated and tough as nails. So, and then we also have this module. This is an ESP flasher, but in a strange form factor. It's the same as the ESP flasher that I use for other things like programming boards.
Squirrels might have chewed on it.
Squirrels might have chewed on it, that's right. But this one is it's just slightly modified so that instead of having a USB socket on this side, which ESP flashers normally do, it has 4 pin headers which go down on and allow it to be mounted. So these are basically surface mount modules. They've got right angle header pins on them so they can be surface mounted. And then it's got the serial interface on this side that goes to the programming header. And it connects to, in this case, pogo pins here, which go onto the programming header on the device under test. So with this, we should be able to flash the device under test. With this, we should be able to communicate with it via CAN bus. Now, the big chunky boy resistors that someone mentioned earlier, these 4 resistors, these are 5-watt wire wound ceramic resistors. They are 68 ohm. And they are across the outputs of the H bridges of the device under test. So this device has these motor drivers on it, and when when we send it a command telling it to move a motor, it turns on those H bridges in different configurations, telling it which way to move. When it does that, the outputs, you can see that there are these test points here. These test points are outputs from the H bridges, and they connect on here. So these are the pogo pins that mount onto those points, and they are used to connect the outputs of the H bridges to these big resistors, which emulates the load of the motor. So we can turn on the motor driver and actually load it, and we'll see the current go up on the power going to the device. We should, these resistors will probably get a little bit warm. They shouldn't get hot, but they should get warm because they'll be dissipating the energy from the motor driver. And we can measure the voltage because there are connections on the tester here going from these resistors to analog inputs on the test chassis, so that we can then turn on an output on a motor driver and measure the voltage that it is producing across the load, so we can verify that the motor drivers are working. So there are a bunch of interesting things in this. This particular device that we're testing, and yeah, it gives an opportunity to experiment with a few different things and to develop functionality within Testomatic that will be useful for all sorts of devices. So that's really cool. Okay, so what I want to do is log into Testomatic. Let's go through this in a couple of steps. Which way I like to do this? I'm going to turn this sideways because you will want to, I'll turn off the microscope light so you can see the screen a bit more easily. Position it about there, and we will come back to it in a second. First though, I want to get a shell on Testomatic. Wouldn't you need a real motor to know what happens? Potentially, you can do that. So one way to do this is to have actual motors on mounted externally and connected via a cable onto the test module. And that sort of thing is something that I've been thinking about as well. But for this case, just driving it into a resistive load is enough to at least know whether the H bridge is working. This is not like a full, it's not for design validation, this is for functional testing. So it's a design that's already been proven and characterized, and we know that it works. What we're doing is just making sure that the H bridges turn on and we get appropriate voltages coming out of them on the right pins. And then if we tell it to go one direction, we get positive and negative, and we tell it to go the other way, we get negative and positive, that sort of thing. So we're testing the assembly, not validating the design. Now I want to get myself a shell on the tester chassis. Test. Oops. That will do. So this, and then we'll get ourselves some. Oops, not that. Not that. What am I doing? That. Looking for the key combination for zoom. And yeah, get ourselves some zoom on it. Okay. Now, LS, what is it? LS USB. What have we got? Via Labs Inc. Hub. Now, oh, here we go. So this, we went through, this was months and months ago now, we went through this whole big process of bringing up the USB hub on the previous iteration of the Testomatic board, and there it is. So now we know at least that the USB hub is working. So what is that? I don't know what that is. MPI 7003. Yeah, okay, cool. That is just because we are plugged into the thingamajigamy. Now, what I'm going to do is, what am I going to do? I want to know if the serial interface comes up. Okay, so let's go ls dev tty. Okay, now what we've got on the screen now tells us two things: what USB devices we have and what serial interfaces we have. So what we're going to do now is plug in the test chassis. This is the first time I've ever actually tried this, so I don't even know if this is going to work. I assembled all of this yesterday, finished it last night, and then I wanted to do all of this on stream. Okay, so you can see that we've got 5 volts and 3.3 volts going to the test chassis, to the test module, and I've turned off the power rails that would go to the device under test. So I can turn on, for example, if I hit that, you can see the green LED has turned on. That is the V in going to the device under test. I'll turn that off. And we can turn on 5 volt rail, 3 volt rail for the device under test. I'm going to leave all of that off. I've got no device under test. It's just the module, the test module itself. So what I want to see now is whether, if I come up to here, I want to see if we've got an ESP flasher. And it looks like we do not. That is sad. Okay, so what there should be is a USB device hanging off this hub. Oh, interesting. Wagon Load says, I had a problem where I couldn't upload to certain Arduinos if they had an incompatible UART. I discovered putting a USB hub between the computer and Arduino, it worked. Stephen says, suddenly John has to end the stream earlier. Won't find it if it enumerates. Yeah, so if I come up to there, this has not changed either. Okay, so we've got some failure. I wonder... I wonder if that is being powered. Hang on. Oh, did I put a... I can't even remember if I put a power LED on that module. Let's see. I did. Okay. Hang on. I'm going to try to turn all of this over carefully, holding onto there, and bringing this over where you can see it. Okay. You see that little blue LED in there? That is the power module on the USB to serial converter. So at least the USB to serial converter is getting power, but it does not seem to be enumerating. Now, Mike had a suggestion about doing a listed devices, ls dev serial by ID. So he suggested ls dev serial there. Dev serial? Is there even such a thing? By ID star. Okay. There are none. Really starting to look like ORAC. TTS. Come on, TTS. Come on, TTS. Catch up. Scott's sent me a picture of a low profile Ethernet cable. Yeah, so what I need is a super thin Ethernet cable. Yeah, Mike says, if it's missing, you don't have any serial devices. Yeah, okay, cool. So it looks like, for some reason, the ESP flasher has failed to enumerate. Well, that is sad. Just thinking about whether it would be related to hot plugging, but I don't think so because USB is designed to be hot plugged. Oh, Scott says monoprice slim run cables are awesome. Yeah. Yes. So where to go from here? I'm not really quite sure. Okay, we can experiment with some other things. What I wanted to do today was, assuming this enumerated, to try doing some, like try flashing firmware to the device under test. But this is going to take some debugging. I'm actually pondering how I'm even going to debug it. I think what I need to do, in order to get to it, I need to get connections onto the module. Or do I? Maybe it's broken out on the top. I'm just thinking about where I can get scope probes onto it. USB. Ah, okay. I've got USB exposed up here. So I can get scope probes onto the USB lines up on the top. And that might help me see if there is anything going to that, to that device. So there are all sorts of ways I could have screwed this up. I could have swapped the USB data lines like D+, D-. That would be the classic one. But yeah, okay. We could look into that, but let's look at some other things first. Let's try. I'll have a look in. I'll get voltage 5 volts. Scan I2C, select module. Let's go to select module, test IO mod. What do I have loaded in this chassis? I think all of the slots are loaded with AD5593R modules. They are. Okay. So now what I need to do is figure out a useful, oh yeah, TechNebula says switch everything off and on while plugged in, check that it is not hot swap. Can you plug and unplug the USB to reboot the USB? Yeah, okay, let's do some quick tests. Let's try cable tie. Oh yeah, I don't seem to be getting audio coming through on the, where have I put the window for, did I close it? Seriously? Did I close the window for TTS? If I did, I don't know why. Oh, now I can't even remember what the address is for it. It was stream something. Oh, cast note. And did I? Oh, can't be reached. Castnote.apt can't be reached. Okay, it looks like TTS is down at the moment. Oh, hang on, no, now it's trying to reload. I don't know. All right, I'm just going to leave that window open. So castnote.app can't be reached at the moment. Yeah, I don't think I've got it minimized anywhere. Okay, I will leave that for now, but cable tie. Yeah, unfortunately, I can't do the music. I'm not going to sing the, the membership song, but if TTS comes back, then we'll do it. Member for 36 months. You've just shown up, Pete. Pete at 29 months. 36 months. 3 years you've been a member, Cable Tie. Thank you very much. I know, to you that probably sounded silly because Cable Tie is a Peter. I was talking about the other Pete. Who, where is it? Back here. This Pete, member for 29 months. Okay. Oh, SK Photo Guy is here. Yes. Now, now it looks like castnote.app isn't loading yet. Good evening and morning, SK Photo Guy. Okay, now what was I doing? That's right. Not that. I want to do that. All right. In fact, I'm going to do that. No. I don't want it in a single thing. I want... Actually, will it work if I do that? Will that fix the formatting? No, it will not. No. Oh well. I'll just have to do it the old-fashioned way. Actually, I wonder if, while true, boop, do ls minor, do clear that, get there, come on, get there. Sleep 2, done. Let's see if this works. Okay, we've made our own little delayer. Watch ls minus c. Oh, says Scott. Okay, with the simple solution. All right, I'm just going to unplug the module. You can't see what I'm doing right now, but I'm going to just pull it out and then put it back in, and we'll see if anything changes in the device list. Nope, nothing changed. Okay, so this time, let's reboot it with the module plugged in. And we'll see if any other device comes up once it has finished rebooting. Oh, Mitchell, you're facing some drama. Mitchell said TTS is offline, had an RCD trip and PC went off and drive failed. Don't have a spare drive, so going to have to replace the drive tomorrow. Oh no. Oh, that sucks. Wonder what tripped the RCD. That's not a not a good thing. Yeah, it's annoying when you end up with a whole lot of extra work like that. That just for no reason. Like it's something happened in the universe. TTS tripped the RCD. Maybe. Maybe. And okay. ls, whoop, and oh, we have a USB 0. That's interesting. Okay, so we do have it now, but we didn't before. Inverter, sorry, not UPS. Yeah, those butterflies, cable tie. That's right. A butterfly somewhere halfway around the world flapped its wings, and Mitchell's inverter went boom. Very annoying. Okay, so we can now see that we have a dev TTY USB 0. Yeah, okay, so Mike says try the ls dev. Okay, so let's do ls, that one. Nice. That's nice. Thank you, Mike. So that could be used to avoid confusion about IDs of things. So, Tech Nebula says your USB hub might have to be set up for removable option. I had the same with my hub before. Really? That is bizarre. I mean, I don't disbelieve you. I'm just surprised because I thought the whole point of USB hubs is to allow hot plugging. So does this mean that you can set up a USB hub so that it won't recognize things that are plugged in after it has been powered up? That is really weird. So the actual, let's see, I've got to find, here we go. So, oh yeah, this is this is the the module that we're just looking at. This is the design of it, and you can see the cutouts and things for the big connector. But what I was trying to get to here was, if we come back to Testomatic, and so it's the where are we? Where am I? I'm looking at this, looking for this one, Testomatic V2.3. So this is where the USB hub is, and also while I'm here, I'm going to open this and this, just for a future reference, because I think I'm going to need this in about 10 minutes time. And then I can close the data panel, bring this across, and then we have chat again. Mitchell said, one positive, I can finally remove the chopstick holding the NVMe drives and put in screws. I hear you saying that chopsticks are not a valid structural replacement for screws. I think they are. I think they are. Okay, so this is the Testomatic schematic, and where's the USB hub? Here we go. So this is the TUSB 2046 USB hub. Data ganged, bus power, test PLL, suspend mode, XMEM, E clock. I would be very surprised if the TUSB 2046 defaults to not allowing hot plug. So this is the USB hub that is in the Testomatic, and then we're on one of the ports. Very strange. Very strange. LS USB. So now we've got this Silicon Labs CP210X UART bridge. This is the ESP flasher device. And if we do -V, I think it is, for verbose, we should be able to come back to here and see, yeah, anyway, all the infos about it. Information will be missing. So this is the UART bridge device, which is, oh yeah, so here we got manufacturer, product serial, it's Superhouse, ESP flasher, and serial 0001. Then this is the hub, BCD device, remote wake up, self-powered, max power. Maybe maybe something in the configuration here tells us whether it supports hot plug. But anyway, that is something to investigate another time, I think. Cable Tie says maybe try the hot plug sequence again. Tabray says, I got sidetracked. Did you try just powering it up with it already plugged in instead of hot plug if possible? Yes, exactly. That is how we have ended up with ourselves in this situation where it is working. So we now have this device. Okay. So, okay, so now we have this with the ESP flasher supposedly working. Let's do this. If I plug this into here, and right now this board actually has firmware on it. This is a known working, like a fully functional, flashed, tested, etc. board ready to go in a known good state. If I touch the touchscreen down here, this will turn on V in, which will send 12 volts to the target, which will power it up, and it will boot and run its currently installed firmware. I hope, if the power connections are all good. So let's try it. Power on. Hey, and look, V in. Oh, and you heard a beep. That means that it has gone through its boot sequence. And you see how this RGB LED is flashing yellow? that means that it is not seeing anything on its CAN bus. What happens is that when this starts successfully receiving, like when it binds to a joystick via CAN bus, this goes green. So right now, this is powered up off the test chassis from its 12 volt connection, and it is not seeing anything else on the CAN bus, which is fine. And we've got power in. We know that the voltage is working. What I'm going to do, because I don't have the clamp, the pressure plate mechanism over this, I'm going to sit in fact, what I'll do is turn it off again. I'll turn off the V in power, and I'm going to grab one of my solder reels, and I'm going to just sit it on top there. There we go. And hopefully that will hold it down. I'm not so sure that it's going to work. It doesn't feel that secure. I think I need to do a proper pressure plate assembly. So I'm going to turn it back on. And will it beep? Yes. Okay, so we now have the board in the test chassis with some weight sitting on top of it, so I can go back to my computer and we can do some experiments. So, back to here. Scott says, ready to see it become a non-working board? Yes. Well, Stephen says, chopsticks are the environmentally friendly version of hot glue. Okay, so now what I'm going to do is, where am I? I am here. So I'm going to go into test runner and targets. All right, I'm going to try doing something in isolation. I'm going to come into targets MCM, and you can see that there is an upload script here. And what this does is call out to ESP tool and upload firmware to the target. So I've got the binaries that have been already compiled that are sitting in this directory, and it tries to push it to the ESP32. Now that is going to dev TTY USB 0, which should be correct. And now in theory, I should be able to upload this firmware as simply as this. And this should go through the test chassis. Now this should, in fact, this is going to be the first time, if this actually works, this is going to be the first time that Testomatic has ever flashed firmware to a device under test through a test module. I've done it many times before with a programmer plugged in, but in fact, literally thousands of times before, because we've been using the version 1 Testomatic for programming boards for ages now, but not with the module. So here we go. Now, what are we expecting to happen? What I'm hoping is that we will see a successful upload from ESP tool, and that once it finishes, it'll reset the board and we'll hear the double beep again. But this could fail for so many reasons, like ESP tool not being installed or something. Let's go. 3, 2, 1, go. ESP tool not found. Okay, let's fix that. ESP tool.py. Where is it? Ah, interesting. Let's see if vim upload. Let's try this. ESP tool Python 3. Oops, back there, and let's try this. I don't know if we actually need to. In fact, we should not need to. So let's go. We don't need to do the do that. Let's do. No, that's the commented out one. So I want to do open and that. Where are we? That. Then I'm going to go. Nope, I'm going to comment comment that out. Go there and, oops, what am I doing? There and there. This should do it. Okay, here we go. Next one. 3, 2, 1, go. Connecting and not connecting. All right, well, that is a failure. Dentistries. Good to see you here. Now, I wonder if that's just because it wasn't pressed down enough. I'm just gonna try it again. I'm now pushing down on the module to see if it gets a connection, because this could just be append, capital A to append at EOL. Oh, okay. At end of line. Capital A. Cool. Now, what am I doing here? All right, so TTY USB 0. We've got, what else? That only happened, that double beep happened just because I was moving the device under test. So, what is going on with connecting to the target? This could be, so my suspicion is that this is a mechanical problem. It's just that this is because I've got the board sitting on top of the test pins and that solder holder stuck on top of it. It's probably a bit of a, all right, I'm gonna do this slightly differently. All right, I'll turn off power to the device under test. It should be connecting through these pins, which are the programming pins, but it may not be. So I'm going to put that on there, get it aligned. I'm going to push it down quite hard now and turn on power, then back to here, and then page up, do the upload again, and see if we get anywhere. No, it should have connected by now. If it was going to, that should have connected. No data received. Well, no, we have a no-go for launch, Gavin. We have a, what do we have? We have a an ESP flash, no-go. Okay, now, what have I screwed up on this? So, Scott says, does the ESP flasher reboot it into flash mode reliably? Oh, actually, something I have just noticed, if we switch back to this view, look at this, the LED is no longer flashing, which means this board, I believe, has been rebooted. I'm going to press reset and we'll see if it starts flashing again. No. So that could be, hang on, it looks like it's not actually sitting aligned properly in the chassis either. Okay. I'll turn off power. I'm going to move it back, but it hard down to the back. Device power on, and I'm going to leave the view on the camera while I do this. I'm about to hit upload, and you can see that the LED is still flashing. Okay, it is failing to put it into boot mode. Interesting. Okay. I wonder if that is related to, all right, I've got an idea for a test that I can do. Another thing that I can try is plug in an external flasher and see if that works. So, I'm going to turn that off. All right, I'm going to bypass the module and find, hopefully somewhere here, I have an ESP flasher. Aha, I do. I have one here, and it'll probably mean changing the, oh, this will also be interesting. I'm going to plug in a second ESP flasher and we'll see what happens. I've got a regular ESP flasher here with an IDC cable on it. So what I'm going to do is plug this into the other USB hub, because, so I'm going to take this off there. In the back of the test chassis there is a USB hub here for doing things like plugging in the label printer or a keyboard or whatever else you might want. So I'm going to plug in the external ESP flasher, which is now powered up, and plug that into the target board and not sit it on the, I'm not going to put it on the connections. I'm just going to leave it here powered up off the external flasher. And now if we do that that thing, ooh, this ESP flasher has not been seen. What is happening with that? What about there? Oh no, I didn't want the watch version. Dev TTY star, that's what I wanted. That is interesting. So we've got a Dev TTY USB 1, but we don't, but doing it by ID, it is not showing up. Gavin, all the we get it, all the departments are there. Everybody is saying go except me. So, all right, let's try this. I'm going to do vim upload and I'm going to just put, I don't need to do that. I'm just going to change this to port 1. So this is the flasher that I just plugged in. And yeah, range no go, that's it. As Stephen says, range no go. All right, so now what I'm going to do is run this through TTY USB 1, which is the external ESP flasher, and we'll see if this manages to do an upload. And go. Connecting. There we go. Okay. So it seems that, and we should hear the beep. Okay, so it seems that we can run with the external ESP flasher, but it was not working with the internal one. Now, why is that the case? There are a few different places where this could have failed. Scott says, John couldn't possibly have swapped RX and TX. Nah, that legitimately is the, Mike says the dev serial is a symbolic link. Yeah, well, we've got dev TTY blah, yeah. So these both exist now. This works, this does not. Dev serial is a symbolic link to what? Anyway, it doesn't matter. Let's ls minus l. Right. No more Apollo 13 quotes. Yep. That's the end of it. So, I'm pausing here to think through what to try next. I think the sensible thing is actually to look at the, to the dev TTY star. Right, Mike. So the destination is this, and the symlink is, like if we have a look in that, that is actually a symlink to USB 0. So if we do, oh, but there are two with the same ID. That would, yeah, that would probably screw it up. So it's going, oh, it's going to TTY USB 1 now. If I unplug that, will it point to 0? I'm going to unplug it. Because the thing is that we've got two ESP flashes plugged in and they will both have the same. Yeah, there we go. So now it points to 0. Yeah, by ID. Yeah, ls-l dev serial by name or by ID. Okay, so that's by ID. By name. Okay. So this is why we use the dev serial, not the TTY. The dev serial, as in /dev/serial, instead of that. Yeah, well, what I did on the other Testomatic is I set up udev rules. So then I map, so that when I plug in different things, I don't actually use dev TTY USB 0, USB 1, etc. because they can swap arbitrarily. I've got udev rules set up to map it to a consistent name. But oh, Scott says by name was a brain fart. Okay, yeah. Dev serial by ID. Dev serial by ID. Yeah, okay. So at the moment what's happening is that this is pointing to whichever of the ESP flashes comes up last, because there's only one here. Right now, that is pointing to, hang on, let's see. That is pointing to TTY USB 0. Now, I'm going to plug in the external USB flasher. ESP flasher, I keep saying the wrong thing, don't know why. And now if I do that again, it's now pointing to USB 1. So we've got two ESP flashes connected to the system, and there's only one by ID because they both actually have the same ID. They're identical. As far as the system is concerned, they are identical devices. And it hasn't given us access to two of them through here by ID. It's only given us access to the last one. Anyway, this is slightly off. Mike says the one issue with is devices which use the same serial. Yeah. And they have the same serial in this case, because I just have a profile in Simplicity Studio which sets the config on the ESP flasher, and they've got serial 1. I haven't been incrementing them. I probably should, but then yeah, that introduces other issues. Anyway, I don't want to sidetrack on that too much. I want to figure out why my why the internal one is not working. So if we look at the upload script again, I've changed it to USB 1. Oh, excuse me. So if I unplug that, I'm going to unplug that ESP flasher, do the exact same thing again, but now I'm going to, what am I going to do? Vim upload, and I'm going to replace that with USB 0 and do the upload again. We've already done this and we know it fails. So I'm just going to try this again for no particular reason, and it fails to connect. So we know it works with an ESP flasher externally. It doesn't work with the ESP flasher that is on the test module. So let's look at why. Coming into here, no, not into there. Coming in and not into there. Into here. Okay, so let's trace this through a little bit. We have USB, no, I'm going to go to the TM mod here. Basically what I'm going to do here is trace through the signal path. Scott says, completely forgot to route the traces. That may that may be the case. All right, so what we've got here is, where's the USB? Okay, USB 1, USB 2, USB 3, USB 4. Okay, so I'm only using USB 1 at the moment, and that is, okay, USB 1P is on pin B18. So I'm bringing USB 1P. This is the test module schematic that we're looking at here. So this is not the Testomatic. This is the module that the device under test plugs into. And where it is going is on here. It is going to this ESP flash module symbol. So we've got D plus going to USB 1P. And where does that go? That goes to up here. It is not, which one is it? That one? Yeah, this one. Okay, so USB 1P. This is the one that we are looking for. View. This one here, the little squiggly line that has been length matched to the negative one. So USB 1P comes down to down to here, which is USB 1P. I just want to make sure that where are we? USB 1P comes down to here. It is on the top, and it is there. Okay. So which D plus D minus should be good. The up high is seeing the flasher. Yeah, that's true. That's true, Scott. So we know that we have signal all the way through to the CP2104, which is on the module. Scott, thank you very much. I was not thinking clearly there at all. We know that our signal path is good. Well, we're fairly confident that our signal path is good all the way to this module. And this is where the, and we also know that this module is getting ground and 5 volts because its power LED comes on, and it enumerates. So that part should be okay. So let's have a look at what's going on the other side of the module. It could also be that the module itself is faulty because it's never been tested. This is all new territory. So we've got these signals coming to the programming header. So this is the ESP flash programming header going to the device under test. What is that? What is TP14? Oh, SDA. Why? Oh, okay. I'm not even using them. SCL, SDA. The test points are there, but they're not routed to anything. There is no signal. So I didn't even need to include those. Oh, there's another signal that hasn't been routed. What I did was I took the test, all of the test points that are on the device under test got converted to test locations on this breakout, and then I routed the ones that I connected the signals I wanted to test, but I'm not even checking, I'm not connecting to I2C. TP squirrels, yeah, okay, so what we've got is these signals here. Let's just check what these signals are. What would be useful would be if I'd named those signals so that I could see on the traces whether where it was going made sense. So let's name the nets on here. This is going to be ESP-TX. No, I do not want to place a label. Name this one. No, don't place label. ESP-RX. ESP-RST. In fact, ESP-RST. Let's do that. No. Stop defaulting to a label. Name, turn off place label. Okay. ESP IO0 and ground obviously is just ground. So that'll already be named. We are not connecting the 3.3 volt out to the device under test because we're relying on its own 3.3 volts being functional. And we actually know that is the case because it boots and runs with its pre-installed firmware. So we don't need to validate that. Now, back to here. Let's have a look at what those signals are. So we've got ESP-TX, ESP-RX, and ESP-IO0, and ESP-RST. Now, do those make sense in terms of the pins on here? Have I rotated this 180 degrees or something stupid like that? Which is possible. I don't think it's the case. Stephen says TX-RX swapping issue. That is also possible. So, the way to check that is, what I'm avoiding doing here is opening the design files for the actual device under test because it is a client's device and that is proprietary to them. ESP flash. So, I am going to, so what I'm doing is looking for, this is the ESP flash, whoops, breakout. So this is what it should be, just to make absolutely sure. Let's put that over here, and, oh, not that, put that over there, and it's rotated 90 degrees, but we can still figure it out. So ESP enable, which is RST, then we should have TX on there, which we do, RX on there, which we do, IO0 down there on pin 6, which we do. We've got ground, which is not actually, there's no test pin in that at the moment because we have ground elsewhere on the board. And this is 3.3 volts, we don't have that connected. So, because we don't need to. The 3.3 volts we are not supplying to the device under test. It has its own onboard voltage regulator. We're giving it 12 volts. It is regulating that down to 5 and to 3.3 volts on board. So that pin there will be at 3.3 volts. Okay, so it could be that there is a fault on that ESP flasher module and it is not driving these pins correctly. Oh, you can see the CAN module breakouts there. CAN boss. So now we're in a situation of testing the tester, which is kind of recursive and annoying. So, all right, I'm gonna get that off. Next, check continuity on the board. Yeah. Wagonline says, what about making the 3v3 a jumper so you have the option in future? Jordan says, should be horizontally mirrored. Oh, I see what you're saying, but no. Okay, so, or are we connecting to the back of the header? Yes, we're connecting to the back of the header. That is a very valid point though. Jordan just pointed out something that could very well have been the issue. So right now we are looking down on the top of the PCB, which is the breakout, that's the test pin carrier board. This is the PCB that is in the test module. You can see the outline there. That is the dimensions of where the device under test goes. Now, what we are doing is looking straight down on top of the test pin carrier board, and the pogo pins will be pointing straight up towards us. So if we look at this header, the pogo pins are coming towards us, and they are pushing into the bottom of the device under test. So the pin out on here should be an exact one-to-one match to the pins on the device under test. Yeah, thanks for pointing that out, Jordan. Yeah, that is something that could be really confusing because we're not plugging down in on top of the device under test. It doesn't have to match like an IDC cable coming down. It's pins from below. Anyway, I'm belaboring the point now. So I think this is correct. But in order to test the ESP flasher module, I need to check. All right, so what I should do is have a look at the design of it and make sure that I didn't get this footprint wrong. So let's do that. Superhouse projects, and where is ESPF mod? I think this is the one. ESPF mod 1.0. Short RCTX and use putty. Next, check continuity on the board. After that, it has to be the flasher module. Yeah, so I'm going to just check the pinout on the module and make sure that it does match what we're expecting to see. So this is the module that is sitting on the bottom of the board, and this is also confusing because we're looking at it from the opposite point of view. Now if I go to TM mod, okay, so what I'm going to do is I'm going to flip this board. I'm going to press the F key, boink. Okay, that has now just mirrored our view of the test board. So we are now looking at the bottom of the test PCB, the test pin carrier board, which is the surface on which the module mounts. And it's 180 degrees rotated. So if we now look at this, this should be a 180 degrees rotated version. And we should have, so we've got ground there, should be in the top left corner, and we have ground there. Then we should have RX. Ooh, interesting. Okay, RX. Yeah, this is something to check, but I'm going to check other things for sanity first. So we should have 3.3 volts, which doesn't actually matter. Okay, second from the bottom should be the IO0 or the EN pin. Okay, second from the bottom is RST, which is, no, it's not IO0 is not EN. So RST, yeah, so enable, second from the bottom, and on the other end should be IO0. And if we come to here, we have this trace, which comes to the dual transistor thingamajigamy. So if we look on the schematic, we'll see that it is that one there, IO0, pin 6. Okay, now let's look at the TX-RX issue. The classics are always the best. So next to the ground pin should be ESP-TX, which is coming from RXD on here. So that is transmit. ESP-TX means transmit from the point of view of the ESP. So it transmits along here and it goes to the RX pin of the ESP flasher. And that is correct. So then, okay, so second one up from ground should be ESP-TX. And let's see if it is. Second one from ground is ESP-TX. And it is. Okay, so I think I'm... Scott says, PCB works as pin carrier board as well as printed circuit board. Exactly. Pin carrier board is also PCB, yes. So this is called the TPCB, which is test pin carrier board, which is also test printed circuit board. Yeah. Pin carrier board, yeah. So, in fact, this is a slight squirrel. GitHub Testomatic. I wonder if I've got the diagram on here. So this is the GitHub repo for the current Testomatic. And somewhere in here I've got a diagram. There we go. No, not there. Here we go. Test pin carrier board, TPCB. That is the thing that you mount your test pins on. So, okay. It may be that this is a defective module. That is possible. But as I think it was Scott pointed out, we should also check the continuity of those connections from the module to these test pins. Cable tie pointed out, it's also polychlorinated biphenyl. Yeah, yeah, PCB, polychlorinated biphenyl, which I think is a nasty stuff. Something you should not be ingesting. I vaguely recall something about PCBs, like the chemical PCB, being a bad thing, a nasty thing. But maybe I'm wrong. I might be thinking of something else. So, okay, we have... Cable tie says, used in large power transformers until the 1970s when it was banned. Yeah. And Jackstech said almost the same thing. Yeah, so... if it was banned in the... If it was banned in the 1970s, you know it must be really bad. Okay, so where to from here? Okay, I think testing continuity is the next logical thing. The reason I'm hesitating on that is it means partly disassembling the test module. I've got to take the bottom plate off to get access to these signals. But that's just what it's got to do. Hang on. Sorry, throat is... Oh, I just realized I still have like half a coffee here. It's stone cold by now, but I still must consume some. Ah, that's better. Okay. Now, all right, checking here. Checking here. I need to make sure that we have continuity from the module to this. Also, something while I'm here, something I wanted to check. There is a whole backstory. Where was that? Oh, no. I want controller ls USB minus V. I just want to see what info I can get out of here. There is a whole backstory that I have not even mentioned to you yet in relation to the ESP flasher, this. And that is that the way this is actually configured is using Simplicity Studio. And I have traditionally done this using my old laptop because I had an old installation of Simplicity Studio version 3 or something. Current one is Simplicity Studio 5 and Studio 6 is now in beta. You can download it and install it. And I did not have a computer working. When I was trying to do this yesterday, I did not have a computer working running Simplicity Studio that I could use to configure the CP2102N. So I ended up installing, the way I did this was, and also I could not get to the board profile that I was using for configuring these devices in the past. So what I did was I installed Simplicity Studio 5 on my laptop, on my current laptop, not the previous one that I used to use for this purpose. And then I plugged in a working ESP flasher and I told Simplicity Studio to pull the configuration data off the existing ESP flasher and create a new profile. So I then use that to flash it to the target, which is the module that is on this one right now. the result is I do not have 100% confidence that I have configured this module correctly. It could be, for example, that the settings for RTS and like the RTS/CTS type control of resetting the target device are not configured properly. So I think that is actually a fairly high likelihood, and I think I need to check that out. It's probably a higher likelihood than a continuity problem. So just reviewing what we've got in the info we've got out of this right now. So we've got generic USB stuff. We're not going to get any configuration info out of this that is specific to the way the CP2102N configures its I/O pins. But okay, at least we know it's got a profile on it and it comes up as that device. One thing that is a change is we know that it has written the profile to it because it's changed the max power setting to 500 milliamps, and the default on Silicon Labs USB to serial chips is 100 milliamps unless you explicitly change it. So the fact that this setting has changed means that it successfully extracted that information from the working ESP flasher and then wrote it to the new one. Scott says going to have to disassemble either way. Yeah, that's true. No, not necessarily true. Not necessarily true, because I can connect to the USB pins and configure the CP2102 from my laptop by connecting into the signals that are broken out on the top of the module. Okay, so num endpoints 2, descriptor type, blah, blah, blah. Yeah, this is not going to tell me anything particularly useful. So the next thing I would do is open my laptop. This is not going to make great viewing. But the next, oh, Keith said, can you just scope the TX test pin during the flash? Yeah, so that is the next logical thing to do, I think. Let's do that. I'm going to turn on the scope. It takes a while to boot, so it's powering up now. All right, let's see if it asserts IO0 or reset. In fact, I can put traces on both of them and we'll see what happens without the device under test connected. Now, okay, here we go, people. Let's do some scoping. So what I'll do is, with no device under test connected, here we go. I am going, so these are the pins right here. This is where the programming ports are. So I need a ground connection and I need the traces on reset and IO0. So which one of these suckers is ground? Where is that? I will find that. Okay. Oh, ground is where? Oh, those are not connected to anything. I don't even need pins in those. Okay, there are a whole lot of places where I didn't need to populate pins at all. Ground. There was a ground. Find me the ground, and yes, I could just do show ground. There it is, ground. Okay, so that one is my ground pin, and then that's reset, and that is IO0. Hang on. Oh, I see what the problem is. Yeah. This is embarrassing. Oh, hang on. Is this still a flip view? Unflipped. No, okay. No, okay. I thought that I had failed to populate the the IO0 pin. But that's because we were looking at a flip view. Okay. All right. So, IO0 is in the bottom left. Okay. This is making more sense now. Now, I want to find that ground pin again. Okay, so ground is... there, okay. So there's our ground pin. And then we want reset is in the top right, IO0 is in the bottom left. Okay. I'm going to leave these on the screen visible to myself while I switch back over to here. And we need to get some probes in place. Now, how can I do this? That one, so ground should be there, and this should be one of the signals we care about, and the other signal we care about should be this one here. Okay, now interestingly they are both 0. Oh, this is interesting. Okay, let's, I'm going to throw up the scope view for you. This is really strongly pointing me towards the module not being configured properly. What is Rigol web control? Here we go. Web control. Look at this. So this is the scope. And I've got, hang on, let's see which way around it is. So yellow is on reset, which is active low, and blue is on IO0. And both of those should be high in normal operation. IO0 is sort of sitting up a little bit. Yes. So, what voltage scale are we on here? 2 volts. Yeah, you can see the trigger level here. If I twiddle the trigger knob, you can see it going up and down. That should, 3.3 volts is somewhere around about there. Both of those signals should be at somewhere around 3.3 volts. And neither of them are. So the reset is held low and... Oh, but... Oh, Pete. No, TTS isn't working at the moment because Mitchell's hard disk failed in his computer. He had a big disaster right in the stream, during the stream while it was on, his computer went boom. So no TTS right now. Okay, now, Scott says, kind of looks like Flasher has a smoke deficit. Okay, but what is interesting here is that if these lines were being actively driven low, they would have stopped the device under test from functioning when it was sitting on the tester, because they would have been holding reset low and IO0 low, and they didn't, which means that this is more and more pointing towards the ESP flasher not being configured correctly. Blue trace is floating, says Scott. Yeah, I think the IO lines are in high impedance. Okay, so my laptop, which is where the... Peter is asking whether I've filled in my form for the 100k sub thing. Yes, I did that a few years ago. I have the plaque, it's on the wall. Yellow seems to be pulled low. Yeah, so let's have a look. Yellow is connected to ESP reset. Now on the module, if we look at the actual ESP flash module schematic, and we look at the reset line, which is this one, it's got a 100 nanofarad cap on it, and it's got this transistor. So these two transistors are arranged in a very bizarro world sort of interlocking way. Oh yeah, Wagonlow says touch with your finger and that should test if the pin is floating. Yeah, I might do that in a second. So, oh, Pete says no for handing it back when you lose all your subs. Yeah, so what Pete is referencing there is that over time, my subscriber count on YouTube is slowly falling through general attrition and accounts being deleted and that sort of thing. And a few years ago, I got the YouTube plaque for 100,000 subscribers, and then the number is slowly heading back down now towards 100,000. So the joke is that when my subscriber count drops below 100,000, I'm going to have to send the plaque back to YouTube. I'll have to give it back. Okay, so this is the thing. We've got the DTR pin and the CTS pin here coming out of the USB to serial converter, and those are driving these two transistors, which are in turn driving IO0 and enable. And what we're seeing is that these two are floating, and one of them is floating, and the other one is kinda, yeah, it's linked through this 100 nanofarad capacitor. So I believe, Scott says, YouTube is in the DPRA. They'll have to pay a tariff if you send it back. Oh, yeah, they can pay a tariff for me giving them back the plaque. So I very strongly suspect that the CP2102N is not configured to drive these I/O pins. And by default, they are not. If you grab a 2102N out of the box and you just put it on a board without configuring it, it is not configured to do like push-pull driving or whatever on these I/O pins. It is configured to leave them as high impedance. So, and that seems to match that matches the behavior of what we're seeing right now. Now, to check this, I am going to, what am I going to do? All right, I am going to go to, I'm going to go out to my car because I've got to go and get my laptop and bring it in here and look at the board profile. Or, alternatively, what I can do is install Simplicity Studio on this computer. Simplicity Studio. Let's do that. For Mac ARM download. It does take a long time though. It took ages to install on my laptop yesterday because it's you install the Studio itself and then it's got to install, like, Simplicity Studio is a wrapper for a whole lot of other things, and it has to do lots of big downloads. Oh, I just got a I hope it's not today. I just got a calendar reminder for a Superhouse barbecue today. And on the old monthly schedule it would have been today. I hope nobody turns up because I'm not ready for it. I don't have sausages or anything. Alright, so right now I'm downloading Simplicity Studio. I'm downloading the installer, which will then take a while to run. Okay, so while that is happening, I am going to I'm going to go to, where are we? find something to stick on the screen. Cable Tie says, what's the new barbecue schedule? Oh, it's every 2 months. So it's still second Sunday of the month, but it is every 2 months. And this month is an off month, so it's not on today. It is, hang on, I'm gonna BQ. And because it is confusing, keeping track of, it's the second Sunday of every second month, and so you really don't know when it is. What I have, I haven't updated the page. Let's do this. I have this page, superhouse.tv/barbecue, odd numbered months, yeah. Yeah, so it is, next one is not then, it is November the 9th is the next one. I should edit this page. Oh, download. Okay, so the download has finished, and I am going to, yes, agree, Simplicity Studio, agree, opening. I was trying to do several things at the same time. The other thing I was trying to do was find this and this and this. All right, here's what we're going to do. Cable Tie says, cool, pity, thanks, pity not today, I might have come. Oh, that would have been good to see you. Okay, Simplicity Studio is installing. Oh, it's only a gig. And that's before you even install the target specific stuff. All right, I am going to drag this up to here and resize it so that you can see the chat. I'm going to hit play, and then I'm going to go for a walk out to my car to grab my laptop, because that might be faster than waiting for Simplicity Studio to install and get itself set up. So here you go. Although you're not going to be able to hear it once I leave because the audio pickup is from my wireless microphone. This is going to be quite a test. I'm going to walk all the way out to my car, which is going to be through several brick walls and some saying when the audio cut out or when it came back. Should definitely be back now because I'm coming back into the lab. Okay, now what are we up to? Fish Tank TV. Okay, lost sound through the brick walls. Okay, that's interesting. Now I'm going to get the get my laptop out. You will not be able to see the screen of this, but I just want to check my Simplicity Studio 5. So I'm booting it on there. In the meantime, I'm going to boot Simplicity Studio on my desktop as well. Open. It just might take a while for the desktop one. Cable Tie says, while I have your attention, anyone in Melbourne happen to have a small steel roller to put curves into 25mm by 3mm steel bar, for example? I need to borrow one for one job. I don't, but maybe other people do. Okay, Simplicity Studio is opening. It is... Okay, so let's see. Open drain, push pull, TXD is push pull, RXD is push pull. Oh, reset latch, high, push pull. Oh, excuse me. My throat is oh, suffering. I didn't get to the mute that time. Wagon Load says, next time I go scuba diving, can I take a metal detector? I could. I don't have an underwater metal detector at the moment. I made one when I was a teenager. But who knows where it is now. That was a long, long time ago. Keith H says, have a sip of coffee. Yes. Okay, here we go. The coffee is now all gone. Okay. Yeah, where is it? I'm half an hour now past. Simplicity Studio is still setting itself up on my desktop. Accept agreements. Yes. Where did it go? Where did it go? Minimize that. That is... Oh, I did have cast node open still. Yeah, but that's now dead. Okay. Mrs. Cable Tie says time to finish. Okay. I should listen to Mrs. Cable Tie. What I was trying to do was... Oh, come on. Get it up on screen. Here we go. Was this. Hang on. Why is the window management not working properly? Come on, give me a resize. There we go. Come on, resize. Resize. Stupid thing. Won't let me resize the window smaller than that. Okay, let's see if I can open. It may be because there is some modal dialog open somewhere that I can't even see. Yeah, anyway. Who knows? This is just the after party. Yeah. Who knows? Okay, what it looks like to me in any case is there is something wrong with the ESP flasher module. I don't yet know what it is. It could be one of three things that come to mind. First is I may not have configured the CP2102N correctly. Now, it's a bit hard for you to see, but here on my laptop I have the Simplicity Studio open, and the configuration at first glance appears to be correct. It's got CTS as open drain, RTS as push-pull, TXD and TXD as push-pull. I've got DTR as push-pull, which is what it needs to be for driving those lines. And then yeah, so DTR here is set to, just confirm this, push-pull, yep. And then RTS, this one here, is set to push-pull. So I think the configuration is correct in this. So that's one of the three things that could be wrong. The next thing that could be wrong is, I had three things in my head, now I can only think of two, an assembly fault. It could just be that there is something wrong, like a, so this is a QFN, the actual CP2102. So I need to check whether there is just an assembly fault, like it could be that the QFN needs to be reflowed or something, or some dodgy connection around these transistors that is not allowing it to drive this pin properly. Okay, so that is an option. Where is that 3.3 volts coming from? Oh, it's got its own onboard regulator. Yeah, which must be working because we are seeing the device. So, although not necessarily, because we've got V-bus coming in here. Okay, so configuration problem, assembly fault, and design fault, of course, is the other possibility. Now, design fault I would rate as a low probability purely because this board is derived from the ESP flasher, and all I did, so what I did when I made this, in fact you can see that the ESP flasher is still, that is still in the description. What I did was I took the ESP flasher project, which is validated, so that's known to work, it's proven to work. In fact, it's what we did just use earlier in the stream for testing. It's this. I took this board, all I did was delete the USB socket and replace it with a 4-pin header right there. You can see where it says USB connection. On the ESP flasher, on this one, there is a USB-C socket. On this, I just deleted the socket and I put this 4-pin header in place. And everything else about this is identical to the design of the, oh, and this is just a, it's just the inline 6 version of the header. So everything else about that is identical to the, I need to check that. No, that is right. Is identical to the ESP flasher module. So I'm pretty confident that the rest of that design is fine. So I think that I give that a very low probability. Wagonload says, if RX and TX are swapped, can you software swap the RX TX? I wonder if I can. TX, RX, I don't... No, I don't think I can. I think the 2102N doesn't allow you to swap TX and RX. They are dedicated pins on the chip. There is no configuration option for that. So I think the most likely explanation here at this stage is some kind of an assembly fault, probably around this part of the board, which is here. It's where this pair of transistors and associated parts drive IO0 and reset. So I'm going to have to do some debugging. But I am really tired. I saw Crispian point out, where is it? Okay, so Crispian said, I'm getting ready to crash out for a while. Flu recovery is knocking me for a 6. Oh, yeah, it sucks. I'm sorry to hear, sorry to hear you're dealing with that, Crispian. And I hope Imi is okay and hasn't caught it from you, or vice versa. So, yeah, I am tired too. I need to take a little break, eat something, and then I'm going to try to figure out what is going on with this ESP flasher. Because that is the next major hurdle to getting this thing working. Okay. Tired. Crispian says, Imi too, she's just tougher than I. Yep. Okay. So, thank you very much for coming along to another stream. and start planning ahead. Remember, we are now 1 month away from the next Super Lab barbecue. So, ooh, I was just thinking, no, it'll be okay. So, thinking ahead, everything open. If you are thinking of going to everything open, I am going to, here we go, this. Hang on, what? What happened to YouTube? Am I still streaming? What happened there? That's really weird. Yeah, okay. YouTube Studio just crashed out on me. Okay, yeah, okay. But yeah, you can see this. Can't open this page. This is the live chat bombed out. Okay, anyway. Everything Open is in Canberra, 21st to 23rd of January. So that is going to be after the January barbecue. For a moment, I had this worry that Everything Open would conflict with the barbecue date, but it doesn't. And I'm going to be going there. I will be attending Everything Open in January. And the early bird tickets I think it's end of this week. If you register, attend, tickets. The early bird price applies up until, I think, the end of this week, like the week coming. You've got 1 week. Oh, here we go. 17th of October. Oh, we've got 5 days left. So if you want to register for Everything Open, then do that in the next 5 days and you get the early bird price, which is, for a hobbyist, it's $50 off. For a professional, it's $100 off. So it is worth doing the early bird registration if you're wanting to go to that. Everythingopen.au is the relevant URL. So, yeah, okay. So, yeah, thank you very much for coming along to another stream. And hopefully by next week, I will, so I submitted a talk to Everything Open about Testomatic. There, I've just disclosed it. I don't know if it's been accepted yet. I haven't got any notification about it. Hopefully it will be accepted. I'm going to Everything Open regardless, but I submitted a talk about Testomatic. And what that does is put a hard deadline on me for having something that I can demonstrate. So I'm going to keep grinding on making progress on these different tasks, like figuring out why the ESP flasher module is now not talking to the device under test. Because by late January, I need to have this ready to demonstrate and very well developed. So I'm going to keep, anyway, the point of telling you that is that I'm going to keep working on this off stream. I'm not going to limit myself to just working on this during stream time, because if I did that, I just would not get enough hours working on it. And I need this functional both for the, hopefully for the Everything Open talk, and also I just need it. The whole reason I started this project is that I needed a test chassis system. So I'm going to get it done. And that means that you will not be seeing some of it. I'll just be doing it off stream and then showing you the result. But I will try to show you as much as I can along the way. So, Stephen says, if it needs to be done by late Jan, probably start working on it early Feb. Yeah. You mean early Feb of 2 years ago, don't you? Okay, I am gonna go. So, thanks for coming along, and I will talk to you all soon. Bye.